Okay, so let me talk about the second part of today's lecture. In the second part, I'm going to talk about aggregation in the MongoDB. So in the relational database, we talked about some aggregation query when we talked about SQL. So it's similar. So MongoDB also provides some aggregation function we can utilize. But MongoDB aggregation function is very powerful. So there are several interesting features we can talk about today. So there's a aggregation framework in MongoDB. So basically, it's a process of transforming and combining uh, documents in a collection. So it's similar to aggregation in SQL basically. So aggregation function in MongoDB will look like this basically. So similar to the other query, we specify the DB first, and then we specify name of a collection, which you are going to do aggregation, and then we specify aggregate function, and then we provide a list of operations we want to perform. So that's basically a basic function aggregation function in MongoDB. So what we are doing is basically here we are creating a pipeline that processes a stream of documents through several operations. And here operations we are able to utilize in MongoDB are these kind of things: filtering, projecting, grouping, sorting, limiting, and skipping. So I'm going to talk about what each operation refers to in today's slide later. So earlier I mentioned that we are creating a pipeline of operation in MongoDB by utilizing aggregation function. Basically, it's like this. So each operator will receive a stream of documents and perform transformation. So let's just say that in the aggregation function, we specify three operations: operator one, operator two, operator three. Then inside the collection in the beginning, there are multiple documents, right? So these documents will be sent to the operator one. So after operator one does the operation, the results will be sent to operator two. And then the results will be sent to operator three. And then final results will be returned back to user. So basically, that's a pipeline of operations we are designing by utilizing aggregate function in the MongoDB. So that's the basic framework in MongoDB. So again, the best way to understand this concept is by trying something. So I'm going to talk about each operator, and I'm going to show you an example of how this works. So the first operator in aggregation we are talking is filtering. So filtering, we can utilize the match operator. Basically, it's exactly same as query. So from the collection of documents, we are choosing documents based on the condition we specify. So basically, we use match operator like this, and we specify a query. And basically, we are filtering documents to select a subset of documents we want to utilize in aggregation. And here, uh, last week, we covered multiple query operations. And you can use all of those query operators here. So it's exactly the same as query. We are specifying a query to select a certain set of documents from the collection. So if you remember last time, we created this CD collection, which contains zip code information with the population information together in the MongoDB. And if we use that collection, we can design something like this. If we want to select all zip codes with a population more than 100,000, then we can use the match operator inside the aggregate function. So we specify DB, CD collection, and aggregate function, and a list of operator we can specify inside here. And the operator in this case we can utilize is a match operator. So we use the match operator, and inside here we specify the query. And the query we are going to utilize is basically this: population should be greater than 100,000, like this. So basically, this is exactly the same as how you use a find function. So let's try this. simply to see how it works. So basically, I can open the new share inside for the test database, and I can specify db.cd collection and aggregate function, and here specify a list of operation, and I have only one operation, which is match, basically, in this case. And the query I'm going to utilize is population should be greater than 100,000. Like this. So if I perform this query, it's exactly the same as how we used the find function in the last class. So it will return 4 documents which has a population more than 100,000. Like this. So that's basically the match operator, which is exactly same as the query operation in the find function. So that's the base operator. And another operator we can utilize is project operator. So basically, the project operator we can use like this. Specify the project operator, and then we specify the expression. So you use this when you want to extract and rename a certain field. And also using the project operator, you can also perform some operations on the fields. So by utilizing project operator, you can do much more powerful things than normal query. Simply instead of simply using read function, it's much more powerful. So type of expression you can specify here is a pipeline expression, mathematical expression, date expression, string expression, and logical expression. So I'm going to show what are these in the next couple of the slides. So pipeline expression is this. So if you remember, when we utilize find function in the query part, we had this returning rules. So we can exclude some of the fields from the document, and we can include some of the fields only, something like that. It's exactly the same. So you can determine whether you want to include or exclude a certain field by utilizing pipeline expression. So if you want to include, you can simply specify field name and number 1. If you want to exclude a certain field, you can specify 0 as a value in that field. And also, so when you design this pipeline expression, if you want to specify and refer to the existing field, you can use this formula. You can use the double quotation and $sign and put the existing field name. So you will use this kind of a thing inside the value when you want to rename the field or when you want to do something else. So for example, if you want to rename the field which exists in the collection into different one when you have the result, then you can use this format. So you can specify new field name, and here you can refer to the existing field name using double quote and then $sign like this. So let's say that you have a field name called POP, right? So we had a POP field, which refers to population in our document in the CD collection. If we want to rename this into population, you can use something like this. So new field name will be population, and then existing field name will be double quote $POP double quote like this. So by doing this old field name will be replaced into new field name in the query result, basically. Yeah, so that's it. So all the field name will be renamed. However, yeah, it does not affect the original document inside the collection because it's query. Only in the result of the query, the new name will be used, basically. So here's some example based on what I just showed earlier. So let's say that we want to select all the zip codes with a population more than 100,000, and we want to do the followings. We want to rename the ID field into zip code field so that it's easier to understand in the result. And we also want to return only zip code and population information. we want to remove other field information in the document. Then here we can utilize match operator and project operator. So first operation we have to perform is this. So basically remember that in aggregate function in MongoDB, we are making a pipeline of operation. First operation is match operation. We have to select documents with a population more than 100,000. Then first we use match operator, and then we select document with a population greater than 100,000. Like this. So this is the first operation using match operator. And then for the now we have to specify the next operation. So we put the comma at the end, and we specify next operation, which will be utilizing project operator. So in the result, we want to rename ID field into a zip code field. So the new name for the zip code will be this zip code field. And then the previous field name, we have to refer to it. So double quote and the $sign and ID field like this. And pre-existing ID field, we don't want to show it. And population field, we want to show and include in the result like this. So that's it. So we can try this in the MongoDB and see how it looks like. So basically here, so yeah, I already have this part, which is utilizing match operator. So I select documents with the population more than 100,000. And for the second operator, I can specify a project operator with, I want to rename field name into zip code. Previous field name was ID. And ID field, I don't want to show it anymore. And population field, I want to show it. So we specify that and yeah, close the project operator like this. If I perform this query, again, it will show 4 documents, but each document will show only the information that I specify. So population, zip code, population, zip code, population, zip code like this. The other information will be excluded from the result, basically. So that is projection, basically. The project operator utilize, which is doing pipeline expression, basically. So next one, you can utilize is mathematical expression. So you can utilize any mathematical expression, and how you use this is like this. So you specify the new field name, which will contain the result from the mathematical expression, and then you specify math expression here. So basically, it will manipulate numerical values using a math expression you specify. And what kind of math expression you can utilize are these kind of things. There's add operator, and as a value, you specify a list of a numerical expression. Then it will simply add all the elements in the list, and it will return the result. There's also subtract operator. In a subtract operator, you are able to specify only a list of 2 elements. So there's a difference. So this is a list of infinite elements, and this is a list of 2 elements. So there's a difference. Because add operator, it will simply add up all the values inside the list. However, for the subtract operator, it will calculate expression 1 minus expression 2. That's why. And also multiply operator is similar to the add operator. You can specify a list of expression, and it will simply multiply all the numerical expression inside the list. Divide is similar to subtract. You are able to specify only 2 elements in the list, and it will calculate expression 1 divided by expression 2. And mode operator is similar to the divide operator. You can only specify 2 elements in the list, and it will return the remainder of dividing the first by the second expression you specify. So mode operator, also, if you are familiar with the programming language, you probably used it before. But in case you are not familiar, if I give you an example, um, let me think. Let's say that if you use mode and the value of first is 5 and the value of second is 3, then the result of this will be basically 2, because uh, if you divide 5 by 3, it's 1 point something, right? So we use 1. So uh, basically, yeah, it provides you a remainder. So 5 minus 3 multiplied by 1 is 2. So it will return 2 as a result. So it will return the remainder of dividing the first by the second, basically. So these operators exist, and you can utilize for mathematical expression in the MongoDB. So let's try to see some example of how to utilize this operator. So one thing is this. Let's say that I'm not going to try this in the MongoDB to save the time, but again, you may try later. So I prepare staff collection with the 2 documents. So first document is for Tom. Tom's salary is 80K and bonus is 20K. And second document is for Jane. Jane's salary is 70K and bonus is 25K. So let's say that we have this information and we want to calculate the total pay of each staff. Then basically the total pay will be salary plus bonus, right? Then how we design this utilizing aggregate function, it will be like this. First of all, let's just say that we only want to, so in this case, we have to utilize a mathematical expression. So we have to utilize a project operator because using mathematical expression is a part of a projection. So first of all, to calculate this information, we use project operator. And we have to specify the new field, which will contain the information. So total pay, we create a new field, and this field will contain the results of aggregation. And what mathematical expression we are going to use, which is add operator in this case, because we are simply going to add salary and bonus. So for the add operator, we are able to specify a list of expression. The first expression, the value we want to add is stored in the salary field. So we have to refer to pre-existing field. So how to refer to pre-existing field? We talked about that earlier. We have to use a double quote and $sign, and then name of a pre-existing field, which is a salary, like this. And the second field we want to refer to is a bonus. So we use the same thing. Double quotation, dollar, bonus, and double quotation, like this. And close the list, close the add operator, and close the total pay, and close the project operator, basically. So salary will refer to the value inside the salary field, and bonus will refer to the value inside bonus field, basically. And it will add these 2 values from each field. And that information will be saved into total pay field. So that's how you can utilize mathematical expression to do aggregation, basically. So that's it. So that's quite simple, right? So another expression we can utilize here in aggregation in the projection is date expression. So again, you can define the new field which will contain the result of the query, and then you can use the date operator and you can specify the data field. So that's what you can do. So data operator, what they do is that they can extract data and time related number from the data type fields, and also you can, as a result, you can receive data as input. So basically, data operator will receive data as input and it will return number as a result. So data operator you can utilize are these kind of things. So you can extract the year from the date and months and week from the date. Also day of month, day of week, day of year, hour, minute, second. All these operator you are able to utilize to extract a certain number from the date data type field. So the example is on the next slide here. So again, we can create two new documents in the staff collection. So there are two documents. First one is for Tom, and for hired field, we simply put the new date like this. If you specify new date like this, basically the current date time will be saved into this field when you perform this code. So after a few minutes, you try this code. Then change document will be made with due current date and time, basically. So let's say that in a very simple way, if we want to calculate how many minutes passed since a staff hired, you can utilize this date expression. So for this one, basically we can use the project operator because we want to utilize the data expression. And then I can so how many minutes passed, then we can use minutes worked or something like that. We can make a new field name here. And in this case, we can use the subtract, right? So we have to subtract from the current minute minus the minute they are hired, something like that. And here we can specify a list of two elements on the subtract operator. The first one is that we want to extract minute from current time. And the second, we want to extract a minute from hired existing field, which is data type, like this. And then, yeah, we close this query like this. So that's it. So basically, this part will extract the minute information, minute number from the current time. So let's say that Tom is hired at 12:30 p.m. and the current time is 12:50 p.m. Then this 50 will be extracted here based on this part. And based on this part, 30 will be extracted. So we use a subtract operator. So 50 minus 30 will be 20. So 20 will be saved here in the minutes worked. So basically, after this aggregation function is done, each step document will have the results of this query results will have two documents with the minutes worked field added for each part. So minutes worked for Tom will be 20, and there will be another number for Jane, something like that. So that's a basic use of and basic example of data expression in project operator. So I will skip this doing on the MongoDB, but you can try later by yourself. Okay, the next one is a string expression. So another data type you may have a lot in MongoDB is string data, like a textual data, basically. So for string expression, you can do the same thing. So you can specify the new field which will contain the result of this expression, and then you can specify the string expression. Then it will manipulate string characters based on what you specify. So what kind of expression you can utilize? There are these things. There's a substring operator. Here you can specify a list of 3 elements. First element is expression, second is start, third is number. What's happening is this. It will return the number of characters you specify starting from the start character from expression. So you have some string value here. So you have some string value here in the expression. Then from the status position, it will take a number of characters and it will return as a result. So basically, it will extract you substring information. So substring function is actually very popular in many different applications. Even in Microsoft Excel, there's a substring. I think there's a substring function or something similar. So you should be familiar with this. And the second one is concatenation operator. So concat operator, basically here you are able to specify a list of multiple expression. And what it does is that it will simply put all the elements together into one string. So let's say that you have A here, you have like B, C here string, then basically the result of this will be A, B, C. So it is simply adding all the string in a one line, basically, so that you can think about that. There's also two lower, two upper operator. It's just simple. Either make expression into lowercase string, or either make expression into uppercase string. So it's a simple operation. So let's just think about this. So we want to select all zip codes with a population more than 100,000 again, and we want to return each address information with the following format. So we have a CD field and state field in each CD document. So for example, if we go back to our MongoDB, in our CD collection, let me see, we have a CD collection we created last time. So if I click view documents, and the first one, if I look at it, basically every document contains CD information here, right? So CD is New York, and also we have a state information. State is NY. So we want to put these together. We want to show it as a New York, comma, NY, something like that. Then we can utilize a string expression to do that. So how can we do that? We can design aggregate function like this. The first one, we want to do that for zip code with a population more than 100,000. So we have to use a match operator first. So here we specify a match operator, and we specify the condition that population should be greater than 100,000. So that's the first operation. Second operation is utilizing project operator. So use project, and then we make a new field called address, and address field should be utilizing concat string expression, and we specify a list of fields. So first we want to show CD name first. So CD name is stored inside the CD field. So we refer to pre-existing CD field using double quote and $sign. And then we want to put this comma. So add a comma. And then finally, we want to refer to a state field. So to refer to the state field, we have to use a double quote and a $sign and specify field name, which is a state. And close this list. And close this concat expression, close address, close project, like this. So if I perform this quick, then the result will be like this. So make a new open share. So basically we can use db cd collection, aggregate function, and list of operation. First operation will be match, which is based on the population greater than 100,000. Second operation will be project, and we make new field address, and utilizing string expression, which is concat operator, and specify a list of expression. The first one, we want to value from the cd field and add comma and value from state like this. Close the concat, close address, close project. And if I click play icon to perform this code, then it will be performed. Four results will be returned. First one is show address New York, NY. Second one New York, NY. Third one Brooklyn, NY. Last one Chicago, IL, like this. So yeah, by this way, you are able to make a new field, and utilizing string expression, you can design a new value here, basically. So that's an example of utilizing string expression in project operator. Okay, so that's it. And the next one is a logical expression. So you are also able to utilize a logical expression in the project operator. So the basic syntax is similar. So you specify the new field name and you specify logical expression here. So the result of logical expression will be saved in the new field as a value. So what kind of logical expression you can utilize? There are these kind of things. The first one is comparison operator, CMP, and you specify expression 1 and expression 2 here. So comparison operator will basically check whether one is bigger than the other or same or smaller than the other. So as a result, it will return 0 if expression 1 and expression 2 is exactly same. It will return negative number if expression 1 is smaller than expression 2. It will return positive number if expression 1 is bigger than expression 2. So that's the comparison operator. And also there is a string case comparison operator. So this is similar to the comparison operator, but it's for case insensitive comparison for strings. So let's say that for comparison operator, if you compare A and small lowercase a, it will consider a small, like lowercase a is bigger than uppercase a, because there is a ASCII code which is assigned to each character. So again, if you are familiar with the programming language, there is you will know this concept of ASCII code. Basically, there is a certain number, unique number assigned for each character, and capital A is 65 basically, and some lowercase a is I think 90, something like that. I don't remember exactly, but something like that. So when we compare the characters, basically it starts from A, B, C, D up to capital G, and it goes back to A, B, C, D, and lowercase g. So lowercase a is considered to have a higher number than uppercase a. So that's the basic thing in the programming language. However, if you use a string case comparison, this operator, it will ignore lowercase or larger case. So basically a will be considered same as lowercase a, something like that.
Sorry to interrupt. Could you make the PowerPoint full screen? It's a little small.
Sorry. Yeah, I forgot about that. Yeah, sorry about that. Yeah. So yeah. So basically that's it. Yeah. And the conditional operator is also there, so you can also utilize conditional operator. So in the I think last time, I don't remember. Yeah, like last time we talked about this kind of comparison operator, right? Equality, not equal, greater than, lower than those operator. You can utilize it here. So you can specify conditional operator, and you can specify a list of two expression. Then it will compare, and it will give the result as a true or false. So expression. So let's say that you specify greater than, and two number are 100 and 200. Then 100 is not greater than 200, right? So this is wrong. Then it will give a false as a result. If it's true, it will give you true as a result, something like that. So you can utilize all these operator, and the best way to get yourself familiarized with this is basically you have to try multiple times. Then you'll be able to utilize all these operator. Also, everything is summarized on the slide, so you can always refer back to the slide if you need any, if you don't remember or if you need any information about this. Other logical expression you can utilize are this kind of thing, and or not conditional operator. You can utilize it. And is basically and in the end operator basically you can list you can put a list of multiple expression and it will return true if all elements are true, otherwise false. Or operator similar, you can put a list of multiple expression, it will return true if at least one element is true. And not operator, you can specify only one expression and then it will return true if the expression is false. Basically, it will reverse the result of this expression. So again, this part, if you are familiar with the programming language, it's exactly the same. So in Python programming language, there is also and or not operator, and it's exactly working as the same way. The last part is the conditional operator. So in Python, it's the same as if statement basically. So it's something like this. So in the conditional operator, you can specify a list of 3 elements. First element is expression. Second element is the value for true expression. Third element is value for false expression. So if the first expression is true, this true expression will be returned as a result. If the first expression is false, then false expression will be returned as true, returned as a result of this query. So, so in other programming language, we have if statement. So basically, this is the same as something like this: if expression and true expression and false expression, something like that. So if this is true, this will be returned. If this is false, this will be returned, something like that. So even in Microsoft Excel, we have a if statement. It works exactly the same way, basically. Okay, so that's all about projection, basically. So there are multiple things you can utilize. And yeah, I think the best is just to try different things. The next aggregation operator that I want to introduce is the group. So there is a grouping operator we can utilize. So here we can specify the group operator and we can specify 2 uh, things here. So first one is grouping condition. The second one is combining rules. So basically, it's similar to aggregation function in SQL, something like summation or calculating average, something like that. So if you remember in MySQL, when we utilize the SQL query, we used the aggregation function like a summation average, and we used this statement like a group by, right? So it's similar to that. It's making a group based on certain condition, and we are doing some aggregation. So basically, that's a grouping operator in MongoDB. So it will group documents by criteria, and it will combine their values. So for the grouping part, we specify something like this. So we specify ID field. Basically, we are going to group documents based on certain condition. So we have to create a new group ID, a new identifier for the group. So we make that, and then you specify the existing field. So based on what you are going to make a group. So whether you are going to make a group based on uh, like a state field, for example, in the CD collection, something like that. And then, yeah, so that's the grouping basically. You are going to use an existing field in a document to make a group ID. And then if you specify the grouping information, you have to specify how you are going to combine the document. So here you specify combining rule, and you will specify the new field, combining operator, and expression. So it will perform combining operation on expression for each group, and expression can be a value or an existing field. So I'll show you more example here later, but that's basically the basic syntax. And combining operator you can utilize is this: summation, calculating average, finding maximum, finding minimum, or simply finding first document or finding last document. So it's similar to the SQL. And also, you may utilize this operator too. Add to set operator or push operator. Basically, what's going to happen is this: when you have when you use grouping, so for each group, either have multiple documents, right, that fall into this group, and then based on a certain field, you want to make a list. Then you can use the push operator. Based on a certain field, you want to make a set. Then you can use add to set operator here, basically. So we talked about each operator earlier, what it means, but you can utilize this here, basically. So let's look at some example here. So let's say that we want to calculate how many zip codes exist in each state. So in the city collection, we have a multiple zip code, and each document refers to different zip code, right? And we also have a state field in each city document. So we want to know how many zip code exists in each city document. So how many zip code? What we have to use? Basically, we have to use the count operator, right? We simply want to count how many document belongs to each state. So if we want to design an aggregate function that performs that gives an answer for this question, then we can use this. So we can use the aggregate function, and we can simply use the group operator first. And inside the group operator, we have to specify two things: ID and basically the group information and the condition. So something like this, yeah. Group information and combining rules. So we have to specify these two things. So the first one we want to specify is the grouping information. So we have to specify what will be the new ID. So based on what we are going to make a group. So here, for each state, we want to calculate this information. So state field should be used as a group. So we have to refer to the pre-existing state field. So use the double quote and use the $sign, and we specify state like this. Oh, yeah, not this, comma. So that's basically the grouping rule, basically. So based on the value inside the state field, we are going to make a group. And then we have to specify the combining rule. So the result of the aggregation will be stored in the number of city, num_city field. So I create that field. And this num_city field will contain count, right? But actually, we don't have a count operator in the MongoDB. So we cannot use that. But what we can do is we can simply use the sum operator. So for each document that belongs to a certain state, we are going to put number 1, and we are going to simply summing up number 1. Then it's the same as a count operator, basically. So we do that, and we finish this. And I think that's it. So basically, this part is combining rule. So let's try this in the MongoDB. So yeah, here, let me delete this, and db cd aggregate function and list of operators can be there. The operator we are going to utilize is group operator. And first, for the grouping rule, we are going to use state field, the value in the state field. And then aggregation we are going to do, the results will be saved in the num.cd field, and the aggregation we are going to do is summing up number 1 for each document in each group, basically. And then that's it. Oh yeah, we need one more, yeah, this to finish the group operator. Okay, then if we perform this query, yeah, here is the results. Actually, yeah, we have some other state too. Let's look at NY. In New York, we have in the state of New York, basically we have 1,595 zip code. In Texas, we have 1,600. Illinois, we have 1,200 zip code. And CA, California, we have 1,500 zip code, something like that. So this, basically this code will calculate how many zip codes exist in each state in our data set. So that's it. So that's one example here. Okay, and the next one is this. There is something called Unwind operator. So what Unwind operator does is very simple. It turns elements in a list into separate documents. So let's just say that we have this document. So you can try this at home by yourself, but we can prepare blog collection with one document here. And the document contains user information and the post information like this, and it contains multiple comments. So basically it's something like a blog. So in the blog, a user key posted this hello world, and Tom and Jenny commented on that post. Then comment field will be a list of a document, and each document will contain user field and the text field like this. So there are 2 comments for this post. And let's say that we are not really interested in the blog content. We are interested in comments. And in this case, basically, we can transform. So in this comment field, it's a list of elements, right? So there are 2 elements, first element and the second element. And if we want to turn each element into a separate document, and we want to do some query, then we can use the Unwind operator, basically. So using Unwind operator, we can transform element in a list into separate document. And if we do that, based on each document, we are able to do some query operation. So in this case, if we want to find all comments made by Tom, so we want to find this comment, then we can design this aggregate function. So on the blog collection, we use aggregate function, and the first operation we can do is selecting only the comments part. So we can use project operator, and we are not interested in other parts in this document. We are only interested in the comments, so we can only include comments as a result. So we can use this project operator first, and then we can use Unwind operator to transform all the elements in the comments list like this. And then we can use the match operator to select the user based on their name matching with the Tom, like this. like this. So by doing this, we can specify three operators. So earlier, as you remember, so aggregation function in MongoDB is creating a pipeline. So basically, it will perform the first project operator. Then, in all documents, only this part will be left. So the second two will be removed from the in the result. Basically, only the comment part will be returned as a result in each document. And then we use an unwind operator. So each comment, each element in the list will be separate document. And then we use the match operator to find all the comments made by Tom, basically. So in the result, in the final result, only this one will be left. So I think it's better to briefly show you how this works. So let me type this quickly in my MongoDB to show you how this works. So on the blog collection, I insert this document basically. The document contains user, key, host, hello, world, and comments, which is a list. The first list, first element is user, Tom, and text is nice post. Second element is another document by Jenny, and the text is cool, something like that. So if I perform this query, basically if I refresh in the test database, there will be blog collection. So if I view documents, then there is one document with the user, key, post, hello world, and the comments. There are two elements. The first element is an embedded document with the user and text. Second is also embedded document with the user and text like this. So there are two elements in the comments. So here, if I perform this aggregate function, so if I use project and comment one like this, I'll show you the result of this first. So if I only use the project operator and if I perform this query, basically what's happening is, so there's a typo. Okay, so if I perform this, then this will be the result. So basically what's happening is that in all the documents, for all the documents inside the blog collection, every other information like user information, post information will be removed, and I will include only the comment field. So only the comment field will be here, like this. So comment field contain a list of two embedded documents like this. And then after project, I'm going to use Unwind operator. So here, it will refer to comments existing field like this. So now if I use Unwind operator, I mentioned that each element will become a separate document. So if I do that, now I have two documents as a result because each element becomes separate document. So Tom's document, so basically Tom's comment and Jenny's comment became separate document like this. And then I use a match operator here to find comments made by Tom only, like this. So because of the match operator added on the third line here, if I perform this, I will have only one result remaining here, which is for comment made by Tom only, like this. So by utilizing this three operator, I am able to search and select only comment made by Tom, like this. So that's how it works in the MongoDB basically. So I specify three operator as a pipeline, and MongoDB will perform each operation one by one, and the result of each operation will be uh, provided as an input for the next operator like this. So that's how it works. So there was basically one example here of utilizing Unwind operator. And other aggregation options you can utilize are this. There's a sort operator. Basically, you can specify the sort operator, and you can specify the field name and specify number 1 or -1. So 1 for ascending, -1 for descending sorting, basically. So you have a result of your query, and if you want to sort those results based on a certain field, you can specify it like this. And field 2, if you specify it, it will be used as a second option to field. So basically, it will be sorted based on the field 1 first, and inside each, if there's a same value, it will be sorted again based on the field 2, like this. Also, there's a limit operator you can use. So you want to return the first n documents as a result, then you can use the limit operator. You can specify the number. And there's also skip operator. So in the result, you want to skip the first n document. And if you want to show the other documents, you can use the skip operator, and you can specify number n like this. There's also out operator you can utilize. You want to store your result of the aggregation query into a new collection. Then you can use out operator, and you can specify a new collection name. Then the result of your aggregation query will be stored as a new collection, which you specify here as your name, basically. So there are a few more exercises here. So let's try to do it really quickly together. So let me show you the answer for this. So let's say that we want to find out top 5 city which has the largest population in our data set. Then we can design this aggregation query like this. First of all, top 5 city. So for each city, we have to make a group to calculate this information. So we can do something like this. We can use the group operator first, and then we can specify the new ID. Basically, we have to make a group for each city. So even though different state, there might be the same city name. So we have to utilize a city and state information together to make a group. So here you can utilize concat operator and use the city name and use the state name together to make a group for each city. Okay, so that's basically for the grouping. So we did the grouping, and then we have to specify the combining rule. So we have to calculate the total population in each city. So total population will be simply summing up all the population which belong to each city for each group, basically. So we specify that. And yeah, that's the grouping part, basically. Okay, and after that, we want to find out top 5 city which has the largest population. So we have to sort the result based on total population. So we specify sort operator, and we want to sort our result based on total population and descending order, like this. And the last operator we want to use is a limit operator, because we want to only see the result of a top 5 city. So use the limit operator in the end and specify only top 5 like this. So that's what we can specify here as a result. So you can try this one. So when you try this, my suggestion is do this first and see the result, and add this and see the result, and add this, see the result. So you can understand how this is actually working in MongoDB. So by doing this, basically MongoDB will make a group, make doing to the aggregation for each city in the state, and it will calculate total population based on the summing operator. And then for this second part, it will sort the result based on the total population. And the last part, it will only show the top 5 result based on how it is sorted, basically. So this is the sample solution for this exercise. You can try it by yourself, given the time limit, and you can see how this works, basically. So this is one example, one exercise of utilizing multiple operators. And the second one here. So we want to find the population of the city Chicago in state Illinois. So there are, again, MongoDB is very similar to the programming language, which means that there are multiple ways of designing the code, which will give you the same result. So one naive way of designing this code for this question is this. So if we want to find the population of city Chicago in state Illinois, basically we can utilize what we designed here earlier, right? So we can use this first part to calculate total population of each city first. Then we are going to put the same code here. So we use the group operator, and then we use ID field based on the concat operator, and we'll put city and state like this. Finish concat, and then we specify the combining rule, which calculate total population using sum operator like this. So this is exactly same as what we designed earlier, right? So basically, we'll make a group based on each city in state, and then we'll calculate total population using the sum operator. And then we'll find, using match operator, we'll find the Chicago ID, Chicago, this comma, Illinois, like this. And this. So this is one way of finding population of the city Chicago in state Illinois. So the first part will calculate total population of each city in each state first, and then we'll use the match operator to find total population of Chicago and Illinois. So this is one way of designing a code for this question. However, this is actually a very naive way, and if you do this, it will be slow. There is actually a better way. The better way is simply changing this part and this part. So doing match operator first before grouping operator. So something like this. We can simply do match operation first. So first we find a document which belong to Chicago and state Illinois. Like this. And then we simply do the group. We use the group operator as we did earlier. So here we specify the ID. Should it be CD? Yeah, you can use the concat, but let me just put CD because only Chicago's data will be left because of the first operator. And the total population can be calculated in the same way using sum operator by summing up all the population value like this. So what I did is very simple. So from the earlier code, I simply put the match operator first before grouping operator like this. So I find documents that belong to Chicago in Illinois first, and then I use the grouping operator to calculate the total population. However, I said this is a smart code and this is naive code. Why is that? Because the speed of operation will be different. So if you try it, you will actually feel it by yourself. The speed of this operation on the smart code is much faster than the previous code. So when I tried it in a different shell, basically in MongoDB, then you can see the speed of operation is actually different. So in the naive code, it took 0.016 seconds, and for the smart code, it took 0.004 second. So basically, the smart code was about 4 times faster when I tried it. Actually, depending on the PC and depending on situation, this time might be different. But if you did it multiple times and if you make it average, then you will get this kind of result. So the smart code is much faster. So what happened is this. In the smart code, basically the documents will be filtered first by the matching operator. And in naive code, all documents were used to calculate group value, and then results were filtered later. So basically, in the smart code, all what we are interested in is only the Chicago, Illinois. So we filter documents first. So we prepare less documents first to calculate and do aggregation. And then with less number of documents, we do aggregation. However, in the naive code, we do aggregation for each city first. So we calculate and we do aggregation for each city, and then we find the Chicago. So basically, more documents will be used to calculate information, and then we find the result. So that's the difference. So here, important thing is this. When you have to do aggregation and when you have to do calculate some information, preparing less document is much better, and it can increase the efficiency and it can increase the performance. Basically, it will be faster. So if possible, you have to always filter first. Basically, you have to always use a match operator first if it is possible. So that's something you have to be really careful, and that's something you have to think about in MongoDB. So in relational database, when you design SQL, these things actually don't matter that much because you have a relationship and you are going to use a primary key, foreign key, no matter what. So these things doesn't matter that much. But in the MongoDB, basically when you design the aggregation, you have to design pipeline by yourself. So you have to be more smart and you have to be more careful when you design this kind of aggregation function. And depending on how you design, the speed of your operation, speed of your query will differ a lot. So that's something I want to point out here. So you have to optimize your code by yourself. So you have to think about how the operation will be performed, basically. So that's a very important part. So yeah, I finished here today. Basically, I covered everything about aggregation function in MongoDB. So there are some parts left here about the map reduce concept, which is a quite important concept in the big data system, which I'm going to, which I focus. So this part I talk more about the conceptual part because MongoDB already had the aggregation function, but I continue this part next time in the next class.